My name is Fadi Zuhayri. I'm a senior director in Big Data AI at Intel. We're part of the Intel Architecture, Graphic, and Software Technology team. I'm joined with my colleague, Jason Dye, Senior Principal Engineer, and the inventor of many technologies, including BigDL, the deep learning framework for Spark, and Analytics Zoo software platform. So really excited to have Jason joining us. And thank you, Jason, for waking up early. He's in the Shanghai time zone, but really exciting he's going to be telling us about exciting technology, about multiple use cases with big customer. You don't want to miss that. With that, so maybe give you a quick outline. We have around 3 modules today we want to cover in this 2-hour time frame. So I thought maybe I'll start giving you a background on what I call the Intel transformation to the intelligent era. And in that, I'll give you the big picture, what Intel is going, and talk about the portfolio, talk about the strategy for analytics and AI. And then I'll give the time back to Jason to deep dive into the technology, talk about Analytics Zoo, the open source software platform for big data AI. And he's going to deep dive into very interesting use cases. His team worked with major customers, including SK Telecom, Burger King, MasterCard, JD.com, and numerous to tell you how they're creating amazing AI solution using Analytics Zoo's open source platform running on Intel Xeon without special acceleration. So very excited to be here talking to you guys. So let's get started. Give you some background about what I call Intel transformation for the intelligence era. In the last 40 years, we have seen amazing technology-led disruptions, and we have made a lot of performance available to a lot of people. In the PC era, back in the 1980s, 1990s, we digitized everything we could. We networked everything we could. And as a result, we got 1 billion people connected on the internet. And that truly changed the way we learned, worked, and entertained ourselves. And then came the cloud era. That's next disruption, mobile and cloud. That era connected around 10 billion devices into the supercomputer of the cloud. And that also changed the way we live and look at computing. So what's going to be the next disruption? I believe we have entered, and probably all of you will agree with me, that we have entered what we call the intelligence era. And our prediction that we will have around 100 billion devices that are going to be connected and intelligent, protecting us, enriching our lives in more ways that you can imagine. But intelligent will require tons of computing, exascale and beyond. Computing that should be equally accessible to anyone and everyone. In fact, we believe that exascale computing should be accessible to everyone, similar to our access to electricity today. So in the pursuit of the intelligence, not only do we need more compute at faster pace than we have ever had, but we also need to be general purpose to continue driving what we call compute democratization and close the digital divide. So probably you all agree that one of the key breakthroughs in our progress for unleashing intelligence is data. As the world, we are generating tons of data every second. We are generating more data than our ability to analyze and understand. The growth of data is linked to several technology inflections occurring today. So the levels of efficiency and scale that the cloud architecture brought to the data center now is moving to the network and the edge. 5G is going to transform network and demand also move more data in the ecosystem. AI, as we all know, is fundamental and is pervasive in our life. AI is turning data from a burden into an opportunity. And lastly, the edge is demanding more and more compute closer to where data is being created and consumed. That, in turn, is driving a new wave of multifunction compute-hungry devices. So data, hope you agree with me, that's not only stresses the need for more compute, but also stresses our whole infrastructure, including memory, storage, and network. So probably you heard, Intel executive talk about Intel purpose to create world-changing technology that enriches the lives of every person on Earth. Our ambition is truly to be the trusted performance leader to fully unleash the potential of data. Our innovation and leadership is anchored across 6 key strategic technology pillars. I stole this slide from the Intel Architecture Day that our chief architect Raja Kuduri presented. I'll really encourage folks to go to YouTube and listen to that Architecture Day. It has very deep dive insight on the architecture and technology. But let me highlight some of those 6 technology pillars Raja talked about, and this is anchoring the Intel transformation to the intelligence era. We start from the process and packaging. We are creating a new wave of computing engine that mix and match IP from different process technology, very modular, so we can use our design IP in any process technology out there. On the XPU layer, we are not only sticking with the general purpose CPU architecture, but we have expanded to other 4 key architecture, including GPU, the FPGAs, the AI special processors. So we are expanding the full spectrum for compute architecture. And on the memory and storage, we are disrupting how we do memory. We introduce Intel Optane technology, which is very disruptive, provide you more capacity than DIMMs at lower price. So it's really changing how we do in memory analytics and creating new use cases with the Optane disruptive technology. And interconnect. With the interconnect, we have multiple technology to allow us to move data much faster in the data-centric infrastructure. And software, we're going to deep dive today on the software, but we have great initiative from, AI acceleration in general purpose CPU, supporting multiple format instruction set, to oneAPI initiative. So this, we have a good section on that. We'll cover that in detail. And on top of that, of course, we cannot forget security. Security is a foundation, and we're creating a lot of technology to make sure we have a trusted, foundation for data. So here's a summary of the hardware portfolio, just to flash, different probably brand names you're probably familiar with, right? So on the compute, what we call process everything. We have from the edge Atom to the PC, to core, to Z on the data center. We have introduced a new discrete GPU, XE GPU. We have FPGAs. We have Habana AI processor. So we have multiple architecture, multiple products in the compute section. And we talked about the memory. We have the Intel Optane memory, both in SSD and persistent memory format, and the different interconnect technology from Ethernet, silicon photonics to Fino, which is the Ethernet switch. And all of those technologies are being optimized, at the software system level. And we're going to double click on all those details later on in our presentation. So what's, the audience is here, analytics AI focus. So let me tell you about Intel's analytics AI strategy. It's anchored about 3 pillars: hardware, software, and the ecosystem engagement. On the hardware, we have our general purpose CPU that we are continually infusing with AI acceleration, and I'll cover that in a minute. And we have what we call the flexible acceleration portfolio, where we have the special XPUs targeted for different workload. Is it an FPGA? Is it an AI workload, etc. And then we all optimized to, creating the bridge between our hardware and software workload. So we're all optimized to take advantage of all the silicon innovation we have inside those chips. And then we entered the software ecosystem. We are heavily engaged in all aspects of the software. So in open source projects, in major framework, the TensorFlow, the PyTorch, you name any framework you have, we have optimized it to take advantage of the Intel platforms. And then we also created open source platform, what Jason going to laser focus on today, to create end-to-end big data AI pipeline. And then we'll talk about those with use cases. And we introduced a year ago, and we have right now at 1.0 level specification, what we call the oneAPI initiative. And I'll talk about that in a second. But basically, oneAPI is a way to abstract the different architecture and create a unified, consistent programming model for the workload to speak to different architecture without being locked into one specific language or architecture. And then we don't stop there. We work with the ecosystem. We work with partners to create solutions. We have Intel AI Builders Program. We do major developer enabling out there in the ecosystem to help more data scientists, more people use AI. And of course, we have the Intel Capital investment arm where we continue to acquire and invest in various startup companies to complete the picture for the AI ecosystem. So here, I wanted to, I touched briefly on the XPU diversity of Intel hardware portfolio, but I wanted to highlight how we have solution from the edge to the cloud. We have the Movidius visual processing unit. We have the Gaussian neural accelerator on the edge, and then we have the discrete GPU, special AI, accelerator through Habana. But the anchor is the general purpose Xeon CPU, and this is so critical. We're putting a lot of investment in making the Xeon AI ready. This is strategically very important, part of that vision of compute democratization, because CPU live where the data reside. And it's important to bring the AI capability and acceleration to the general purpose compute versus trying to move the workload to very expensive accelerator. Even though we believe there are places, workloads, specialized workload, you need those special accelerators, and we are supporting that, and we are investing in that space. But the more we can move to the central CPU ecosystem, I think the better for the industry overall. Then this year, I wanted to highlight through this slide the different, the progress of the AI infused in our Xeon CPU. So we support AVX, VNNI, and next generation we're going to support the advanced matrix extension, and we support different data format like BF float 16. So all those are standard part of your
Fadi.
Yes.
Most of the, I'll call it the rest of the industry has kind of gone to the use of GPUs to perform AI model training, in some cases inferencing. I notice you have GPUs in your portfolio, but you're not necessarily focusing on that to provide AI solutions. I mean, you've got Habana and the other solutions for the edge. I mean, and it all ties back to the central XPU Xeon architecture. I'm just trying to understand why you're different in that regard.
I will not position it the way, but a good observation. Our discrete GPU is fairly new. We just launched the XE discrete graphics out in the industry, so we just announced that last week. But like I said, the philosophy is because right now Xeon CPU is mature. All enterprises or cloud providers are already using that general, advanced Xeon infrastructure. So, and the data lives there. So we're trying to facilitate to reduce TCO for our customer by trying to maximize their existing investment. That's why we put a lot of effort into, optimizing for our Xeon. That's why we create a lot of software open source project to leverage the general purpose CPU for AI. But this does not mean, we're not going to embrace. Actually, as a matter of fact, we are embracing that's why we launched this major oneAPI initiative. Actually, it's a good segue to talk about the next slide. So we truly believe that there are different architectures out there that require for the next intelligence era, from scalar to vector to matrix to spatial, and recognize each architecture have a different programming language, different compiler, a different way, and some of them are locked, closed, like say CUDA, for example. So our vision is, and it's translated into reality right now, is we have launched what we call the oneAPI initiative to create a consistent common interface to speak to all those diverse architecture. So the people on the top layer, they write once and they can scale to any architecture depending on their workload, right? And this is an open specification based on data parallel C++. It's not locked, and even we provide. So we launched a spec, back last year at Supercomputing, and now we just a couple of weeks ago announced 1.0. But I want to talk about the oneAPI product implementation. So not only we provide core libraries and languages, but we even have compatibility tool. So people who have CUDA code, they can even, port it and, use the oneAPI abstraction layer to seamlessly work across architecture. Doesn't matter if it's Intel architecture, Intel product or competitor product. We believe in that openness. We believe on having a single common interface to allow the flexibility for our data scientists out there. So did I answer your question, right?
Yeah, and more. Thanks.
Perfect. Okay. Good question. So that's what I wanted to briefly talk about oneAPI, and we have different resources toolkits, what we call the basic, the core for library languages and compatibility tools, but also we have domain specific toolkits for HPC, for IoT, for rendering, and then all free, available. You can download them. And also we introduced what we call the DevCloud. Anybody can come free of charge, without downloading, buying any hardware or doing any install, go start practicing, using DevCloud to use oneAPI and, prototype their workloads with that language, right? So I'd really encourage everyone to take advantage of those capabilities and join us in that open, unifying movement we introduced at Intel a year ago. So in summary, maybe that's a good slide to summarize the AI software stack ecosystem we have at Intel. So I touched a little bit on the oneAPI layer, how we at the low level, the OneDNN, OneDAL, OneCCL, all of those trying to optimize, provide the best optimization from the hardware layer infrastructure, for is it CPU, GPU, or any accelerator. But also, like I mentioned, we work in the open source community. We work with all the key.
So Fadi,
yes, go ahead.
The OpenAPI supports like NVIDIA GPUs and AMD GPU, and those, just about anybody's accelerators as well. I mean,
Yep.
I know that would be the intent. I mean, what's the reality today, I guess?
So again, oneAPI is fairly new. So as a previous slide talked about, like we announced the concept back in Supercomputing 19, and now a couple of weeks ago we announced the 1.0 specification, and more to come. And then we just also announced that gold version of the product implementation. So we have the compatibility tool. So it's open. It's a collaborative industry effort, but the bridge is there. So now it's execution detail. Would the Intel engineer go port the CUDA code for the customer, or would that's, but from an architecture technology vision, the bridges are open to all architecture, regardless of competition. And then, of course, I'll suspect Intel would be focusing priority of implementation on an Intel specific product, but does not mean, it's an open community, anybody can contribute. So it's an open, not locked interface architecture. So we want the industry to adopt that. That's the key, right? Yeah.
I gotcha. Thanks.
Right, sure. So on that, we cover a broad spectrum ecosystem from big data, machine learning, deep learning, all the key framework, and I talked about the low-level performance, right? And then we have what we call the end-to-end platforms, the analytics zoo for big data AI, which is going to be the focus of our next two module presentation today. And we have so many customers we've been working with and trying to enable and bringing key new AI use cases solution to that, from agriculture to telecom. And I put a link there for people to go check out the various solutions created in different industry segments. And but as we have been talking to those customers and creating solution, we have noticed the trend and the demand from those key customers to what we call create an end-to-end AI pipeline. From data ingestion to feature engineering, pre-processing of your data, to training your model, to inference and deployment. And we saw that a lot of big customers have their data already existing next to their CPU, next to the Xeon. So they wanted, common environment to do all the development and from A to Z. And that's how the Analytics do open source platform concept Jason created and work in the ecosystem to make it available. And that's why today we are thankful for the opportunity to talk to you about this amazing open source, free of charge technology that is enabling data scientists to create end-to-end big data AI solution. And I don't want to steal the thunder from Jason because he's going to talk in details about the technical features, capability of Analytics Do, and he's going to couple that with multiple use cases from key customer real deployment out there, how they use Analytics Do on Intel Xeon to create real business solution and saving lots of money without special acceleration.